Today we're going to be doing applications using trig functions. Some definitions we need to know before we start our applications. One of them is angle of elevation. The angle of elevation is formed by the line of sight and the horizontal plane for an object above the horizontal. So if you see here, we have our line of sight, we have the base that would form with the triangle, and our angle of elevation. So the angle will be represented above the horizontal line. So we see again here, this is the angle of elevation or horizontal line. The angle will be above the horizontal line. The next definition is angle of depression. This angle is formed by the line of sight and the horizontal plane for an object below the horizontal. So we still have a line of sight that is formed with our horizontal line, and so our angle is right below the horizontal line. So we have an example of here, we have a picture drawn out, we have the ocean, we have a cliff, maybe an observer is up here up top where we have a line of sight, and of course our horizontal line, our angle of depression's here, that will be below the horizontal line. So looking at them both. So again, angle of depression, remember depression will be below, and then the elevation will be above. So keep that in mind when we're looking at our word problems today. Example 4. A kite is flying at an angle of elevation of about 55 degrees. Ignoring the sag and the string, find the height of the kite if 85 meters of string have been let out. So we talked about angle of elevation earlier on. We are finding the height of the kite. So let's first draw out our right triangle. So if you've seen a kite before, a kite is going to be flown at an angle. So there's a string. So that's going to be representing our hypotenuse. So our angle of elevation is above, so 55 degrees goes there. Okay, so we have find the height of the kite, because we want to know how high is it off the ground. Well, that will be x here, and it's saying find the height of the kite if 85 meters of the string have been let out. So 85 meters is the hypotenuse, because it's saying that the string of the kite is 85 meters long. So in saying that, we have the opposite side from the angle, and then we have the hypotenuse side for 85 meters of the angle. So opposite and hypotenuse is sine, so sine 55 degrees equals x over 85. X is up top, so we multiply. 85 times sine 55. Type in the calculator to see what x gives you. Once you type that in, you will find that x gives you 69.6 meters, and that is how high the kite is off the ground. This next example is a little bit different than what we've seen. So we have two things going on. We have a 5.5-foot person standing 10 feet from a street light, and it casts a 14-foot shadow. What is the height of the street light? So with this saying, we're going to have to draw our picture a little different than we had before. So we're going to first start out by taking and labeling our picture. So we have a 5.5-foot person. So 5.5-foot person. This person standing 10 feet from a street light. He's standing 10 feet from a street light. And he casts a 14-foot shadow. What is the height of the street light? Well, now from here, I'm just going to connect it to make one triangle. Now, I know it looks kind of sloppy, so what I'm going to do is recreate this. So we have a bigger triangle. Basically, I'm making two triangles. You've seen something like this before in Unit 1. Here is x, 10, 14, and 5.5. So what it's asking is the height of the street light. Well, this one we actually have to do a little bit more. what you could do is use some skills that you learned from Unit 1 about similar triangles, or what we're going to do right now is use trig. Well, to find x, we need to have an angle. Do you realize that we do not have an angle here? We need to find what this angle is right there. So we need to do the inverse of a trig function. If you notice, this right here is a triangle, a smaller triangle. So I want to pull it apart and show that, okay, we have 5.5 there, there's theta, what we're looking for, and then 14. So we have theta, which is unknown, and we want to find what it is. Well, 5.5 is opposite, 14 is adjacent. So we need to do the inverse tan of 5.5 over 14 to find the missing angle of the triangle. You should get theta equals 21 degrees. And I rounded in there as whole numbers. So theta is 21 degrees. Well, now I want you to look at a different triangle, and it's the larger one. Okay, so now we have a larger triangle, and we are finding x. The base will be 24. Now 24 we got because we added 10 and 14. And theta down here now is 21 degrees because this angle right here is shared by both triangles by the reflexive property. So since the angle was 21 degrees in the smaller triangle up here, it will also be 21 degrees down in the bigger triangle. So when we're solving, we need to have our sides labeled. So x will be opposite of 21 degrees, 24 will be adjacent. So we will be using tangent again. So tan, now 21 degrees, equals x over 24. So x is up top, so we're going to multiply. So it's going to be 24 times tan, 21 equals x. So type that in the calculator to see what the height of the street light will be. Your answer after you plug it in will be x equals 9.2 feet, and that represents the height of the street light. So example 6, the angle of depression, we haven't done an example of the angle of depression yet, from the top of the tower to a boulder on the ground is 38 degrees. If the tower is 25 meters high, how far from the base of the tower is the boulder? So first you want to sketch out a right triangle. Okay, your tower, your house, your building, that will always be right here. Okay, so our boulder will be down here, our tower will be up here, and our tower is 25 meters. So it does say now that our angle depression from the top of the tower, which will be up here, okay, to the boulder on the ground is 38 degrees. So remember, angle depression is below the horizontal line. And so there we have to label 38 degrees, and then we have to label our x, which is how far from the base of the tower is the boulder, which will be down here. Now usually when we do a triangle, you know, finding missing angles or missing sides, our angle will always be inside the triangle. So that means that 38 will be down here. Now the reason for that is because of alternate interior angles are congruent. You talked about that in Unit 1, and that right there will let you know why it's 38 degrees. Now, just something to consider when you're doing application problems, your angle will always be in the bottom corner, whether it's facing, you know, this way or that way, like the example here. Your angle will always be on the bottom of the triangle. It will never be up top unless it's given that way in another regular problem. But here with application, your angle will always be in the bottom. So with saying that, we need to label our sides, adjacent, opposite, you know, whatever we may have. So with 38 degrees here, x is adjacent, 25 is opposite. So we're going to be using tangent. So tan 38 equals opposite 25 over x. So with all these examples that we have done, we have had x being up top, which meant we multiply. Well, here we have x in the bottom. So obviously we will not multiply, we will divide. And what that means is you're going to swap the places of x and tan 38. So it's going to look like this when you type in the calculator. 25 divided by tan 38. So you type in the calculator and see what you get. X should equal 32. Even if I round to the 10th place, the 100th place, it will always, in this case, round to 32 because it came out to be 31.9985. So that's just going to round all the way up to 32, and 32 meters to be exact. Thanks for watching. Don't forget to like or comment.